Problem number 11 from exercise. Potential energy of particle performing linear SHM is 0.1 pi square x square joule. The mass of the particle is 20 gram. Find frequency of SHM. We have to find out frequency of SHM. Now here given. So this is potential energy. This 20 gram is the mass that you have to convert into the kg. So you can write 20 into 10 raised to minus 3 kg. And frequency we have to find out. In a formula of potential energy. So solution here, potential energy is this, mass is this. So potential energy is given by formula 1 by 2 m omega square x square. Now here omega we can write. Omega is 2 pi into frequency, 2 pi f. So it's omega square. So 4 pi square f square we are written. Now potential energy is given in term of x. So here when we substitute potential energy, then x square get cancelled from both the sides, and you have to solve this equation for frequency. As we substitute the value of this potential energy, then this x square get cancelled, pi square and this pi square get cancelled, as well as this 2 2s are 4. We get here, after simplification, 2 m f square is equal to 0.1. After this we get this step. Now we have to solve this for frequency. So let me substitute in a formula of frequency. F square is equal to 0.1 divided by 2m. Let me substitute here values and we do the calculation to find out answer. So 0.1 divided by 2 into 20 into 10 raised to minus 3. That 20 into minus 3 we can write 2 into 10 raised to minus 2. And this 0.1 we are written 1. So here it is 20. So we have to solve this. And after solving this we get f square is 2.5. Means frequency is root 2.5. Root of 2.5 is coming 1.581. And this is the answer for the frequency. Now problem number 12. The total energy of body of mass 2 kg. So this is a mass. Performing SHM is 40 joule. This is total energy. Find speed while crossing center. So speed at center is the maximum. So you have to find out maximum speed. So V max is question mark. Let me write the given here. Mass and total energy is given. Now we can use a formula of total energy. 1 by 2 m omega square 1, or we can use the directly here formula. So at the center, so body having only a kinetic energy. Means at mean position, the total energy is equal to kinetic energy. So we can use the formula of kinetic energy. Speed of the body while crossing the center of the path is maximum. Total energy entirely the kinetic energy, or we can write, so total energy E is equal to kinetic energy. And here kinetic energy is given by formula 1 by 2 mv max square. Now here maximum velocity we have to find out. Everything is given. So v max is equal to under root 2e by m. Now let me substitute the values. So we get under root 2 into 40 divided by 2. 2 get cancelled. So here root 40 is coming 6.324. It's a velocity, so meter per second. So this is the speed while crossing center of the path and speed at mean position. Now problem number 13 from exercise. A simple pendulum perform SHM of period 4 seconds. This is capital T. How much time after crossing the mean position will the displacement of bob be 1/3 of its amplitude? So x is equal to a by 3 they given. So displacement is or 1 by 3 of amplitude you can write. So after crossing mean position, so we start with the displacement formula. If particle start from mean position, displacement is given by x is equal to a sin omega t. So here t is 4 seconds, x is a by 3. So displacement of particle starting SHM from mean position is given by this formula. Now in that omega is not given, but here period is given. So we can write omega is 2 pi by t. Then we get formula of displacement is equal to a sine 2 pi by t into t. Here. So x we substitute a by 3. Then here a by 3, a by 3, sorry, a and a from a by 3 get cancelled. So here we transfer this sign to this side. Sine inverse of 1 by 3 means this 0.333. Just I told you the value of this. It is coming 19.47 degree. Okay. Now we can simplify this for small t. Period capital T is 4. And pi we can substitute 180. Or we can do one thing, we can convert this into the radian and then we can substitute pi 3.14 also. Okay. Now here they converted, no need to convert this. We can write like this, small t is equal to 19.47 into capital T by 2 pi. So 19.47 multiplied by capital T is 4 divided by 2 into pi is 180 degree. So if you solve this, whatever the answer you are getting, it is the time. Or you can convert this quantity into the radian and then you can substitute pi as a 3.14, or this pi get cancelled. In that way also you can do. So you are getting the same equation. Same equation you will get. Now after solving this we get 19.47 divided by 90. So you can see here it is 2 2s are 4. So 2 here it is 90. So 19.47 by 90 we get. And it is coming 0.2163. Question number 14 from exercise of oscillation. A simple pendulum of length. So here length is 100 centimeter means 1 meter. Perform SHM. Find restoring force acting on its bob of mass 50 gram. This is a mass. So 50 gram means 50 into 10 raised to minus 3 kg. Or you can write 5 into 10 raised to minus 2. When displacement from mean position is 3 centimeter, so it is a x. So it is 3 into 10 raised to minus 2 meter. And what we have to find out? Restoring force. So restoring force So given we enlist here, so length, so it is equal to 1 meter. 50 gram means 50 into 10 raised to minus 3. It means that 5 into 10 raised to minus 2. X is 3 centimeters, so we can write 3 into 10 raised to minus 2 meter. And G we can use 9.8. So we know that restoring force is F is equal to minus mg sin theta is there, but we are not using minus sign. We consider only the magnitude here. This theta is very very small, so we can write F is equal to mg into theta. Now here theta also we can write x by L. So we can write this formula mg x by L. Now we substitute, everything is given. We have to substitute and we have to solve it for F. After substitution of the values and doing the simple calculations here, we get this is the force 1.47 into 10 raised to minus 2 Newton. ठीक आहे. लक्ष द्या, आन्सर नेहमी आल्यानंतर you try to write it in standard form. As you get the answer, immediately you try to write down in standard form. Now problem number 15 from exercise. Find change in length of second's pendulum if acceleration due to gravity at a place changes from 9.75 to 9.8 meter per second square. And you have to find out change in length. First thing, you know that period second's pendulum means t is given 2 seconds. So as we substitute t is 2 seconds, then we get length is equal to g by pi square. So you have to find out change in length. So you find out L1 and L2 by taking this first, this is G1 and this is G2. Find out L1, L2 and the change in the length is the difference in the length. So here you can see here the given G1 is given, G2 is. Then after that you use this formula. By using that you will get L1 and L2 and then difference you have to take. Now let me find out L1 by using a formula G1 by pi square. So we get 0.9876 meter as a L1. Similar manner we find out L2, G2 upon pi square. 0.9927 is L2. Now change in length is difference in the length. L2 minus L1. As we take L2 minus L1, we get 0.0051 meter as a change in length. Question number 16. At what distance from mean position x is equal to question is the kinetic energy of particle performing SHM of amplitude 8 centimeter 3 times the potential energy. You have to use formula kinetic energy is 3 times the potential energy. And then you have to substitute kinetic energy formula, potential energy formula. You have to cancel the common term and you have to find out x. So kinetic energy is 1 by 2 m omega square a square minus x square, and potential energy is 3 multiplied by 2. 3 multiplied by 1 by 2 into this m omega square x square. Cancel the common term and simplify this equation for x. You will get answer. So answer for this question is 4 centimeter. Displacement is amplitude by 2. Amplitude is 8. 8 by 2 is 4. Now question number 19 from exercise. They given here x is equal to a sin omega t plus b cos omega t. Here a, b and omega are constant. Prove that amplitude is given by this formula. Now here we have to adjust here the standard form. So x is equal to a sin omega t plus b cos omega t. Now the same equation we can write here. A sin, this omega t we can write omega t plus 0. And this cos, we are written cos in term of sine. So sin omega t plus 90. You know that sin omega t plus 90 is cos omega t. Comparing this equation with standard form, the standard form is this. We learn composition of SHM. In that composition of SHM, we learn this is standard form. Now, as we compare with the standard form, you come to know that how much is A1. A1 is A, A2 is B, alpha 1 is 0, alpha 2 is 90. So we get this A1, A2, alpha 1, alpha 2. Now, resultant amplitude is given by this expression. In composition of SHM, we obtain resultant amplitude formula under root A1 square plus A2 square plus twice A1 A2 cos of alpha 1 minus alpha 2. Now let me substitute the values. So A1 is A, A2 is B. Okay, so A1 square plus B square plus 2AB into cos of alpha 1 is 0 and alpha 2 is 90. So we get cos 0 minus 90. So cos 0 minus 90 is cos minus 90. Cos minus 90 is similar to the cos plus 90. So we can write this. Now cos 90 is coming 0. So this term get cancelled. 0 into 2ab 0. So we get under root a square plus b square. And this only we have to prove here. Hence